Hello, everyone. Today we are going to discuss data mining and data analysis by using Python. In this lecture, we will cover more than 80 data analysis and data mining techniques, as well as some basic statistics and graphical representation or visualizations by using a datasets. So let us get started. First of all, we have to open a Anaconda. So let's go and open the Anaconda. I should go there and click on the Anaconda, and then click on the Anaconda Navigator. Anaconda Navigator is opening. Give it a second. Yes, now it is coming. Okay, now it is opened. Let me go to the spider, which I like very much. At the end of the semester, I might show you how to also use Jupyter Notebook. So now I click on the spider. It is opening. Yes. Okay. Here is my here is my spider. It is open. It looks like this. And we can make the Windows like view and Windows layout. If you want, you can take a Windows layout like horizontal split, something like this, side by side or vertical. So I choose this is called the horizontal split. And if we want, we can also do the vertical split. Here is the vertical split. So I can also take a look in the vertical format. Okay. After doing this, let me go and open my code that I have created. Here is my desktop. Here is my code that I have created, week 2, and this is the code that I have in here. So this code I have opened. Okay, so now there is a more than 80 problems in here. If you take a look at that, all of problem 84 until 82, 83, 84, all of this is very beautifully leveled with the problem numbers. So now these 84 problems, what line of code is doing what, how do I know that? In order to know that, we also have to open a Word document. So let me open the Word document from there. This is called the class practice document. I have opened this Word document. So this Word document now open. So data analysis, data mining, and basic statistics. This is a material. This is the Word document. In this Word document, we are using a longitudinal data. And by using this longitudinal data, we will do all data analysis, data mining, and basic statistics by using Python. There are altogether 84 data analysis and data mining problem in this document. Okay, we will go one by one. Let me start reading. So a longitudinal data name as class practice data.csv. The data is in the CSV format, is simulated with the following variables. What are the variables? ID stands for identification number, race, 1 stands for Caucasians and 2 stands for African American, income, family income. It has 8 levels. Income variable has 8 levels, starting from very poor to very rich, super rich. And age of the person, smoking status, whether the person is a smoker or not, systolic blood pressure and diastolic blood pressure. Let me explain what does this mean. When we go to the doctor, on doctor took our blood pressures, their blood pressure machines gave two readings. Okay, the high one and low one. High one is called the systolic, low one is called the diastolic. This is called the systolic and diastolic blood pressure. If a person's blood pressure is highest one is around 120 and lowest one is around 180, that means that person has a very good blood pressure. Okay, so you understand what is systolic blood pressure and what is diastolic blood pressure. And then we are using height, weight, waist measurement, body mass index, and visit number, sugar, breast, hips and arms, and total cholesterol, triglyceride, high density lipoprotein, low density lipoprotein, pulse, waist, a number of login to the device, and time to an event or sense time to an event or censoring. So that means if cancer patients or the business that are running a time to bankruptcy, it is an event. And if no bankruptcy, that means the time until we finish our study. So here time to an event or time to censoring. Suppose business study at 1980 and then business went bankruptcy in 2007. So 27 years they did the business, and at 27th years 2007 they went to the bankruptcy. So that means if there is a bankruptcy, we will create an censoring variable or event variable known as the 0 and 1. If there is an event, then 1, and that means bankruptcy. Yes, that means 1. No bankruptcy, so that means it is 0. So that is the event variable is also called. Data has been generated in such a way that most of the data analysis, data modeling, and test of hypothesis can be conducted with this data. This is a biomedical data you are using, but after completing all of these 84 problems, your expertise in coding by using Python will move from very basic or no knowledge to the at least intermediate level. Okay. And the homeworks that I am assigning has 30 problems. So if you understand all of these 84 problems, then homework problems will be easier for you. In addition to that, that will make you a very good coder by using Python in Spider platform. Okay, in Spider tool. Okay, let's get started. First thing is what? First question is, import pandas, numpy, seaborn, and operating system libraries to the Python. So these are the libraries. Some other people, they develop these for for libraries. So let me make it bold. Let me make it bold, and then these are just packages. Some other people develop these things packages. So our purpose is to import these packages first. Let me take you to the Python. And so this is the first question. I am importing these things in my Spider tool. Okay. So I selected these things, Control Enter. So these packages are now imported. And okay, the importing of this package is done. This is called the console, as I mentioned in my last lecture, and this is called the editor. In this editor, I will write, save, edit the code, and finally you are gonna submit this Python script file as your homework to me. Okay, so now after that, now I want to know what is the built-in after opening Python, what is the built-in working directory. So that means what is the current working directory. In order to know that, if I run this, my current working directory is the drive C user and MC264. So this is my directory. If I save my data in this directory, then I can easily import the data in here. On the other hand, if I want to use another drive as my directory where I will save my data, I will save my code, I will save everything in that folder, then I can declare that path of the folder as my directory, which I'm going to do next. So this is OS means operating system, get current working directory. So OS stands for operating system, get, C means current, W means working, D means directory. So current working directory. I do not want this directory and do not want to save everything in that. Instead, I want to create a folder for the week 2 materials, and I want to declare that folder as my working directory. What is that folder? This is my folder. This is my folder, and I have created week 2 folder in this SBU in the desktop. In the desktop, I have a SBU folder. In this SBU folder, I created week 2 directory. So in that way, I can get that. Okay. This is my third question. And then fourth question is, how can I read the data from the directory? So as I declared the directory, on that directory, I save the code class, I save the data class practice data. So I read it in here. So I am reading it in here, class underscore practice underscore data dot CSV. So now my data has been imported to the Python. Okay. So see, before bringing your data to the Python, you have to declare your working directory. After declaring working directory in this week 2 folder, you have to have a data. Okay. So remember, you will make a folder and you will make that as your working directory. And after doing that, if you import your data, homework 2 data, you just write the name here, homework underscore 2.csv. In that way, your data will be imported to Python before starting data analysis and data mining, as well as visual representations of the data. Okay. After doing that, we want to do what? After doing this, then we want to do reading data without declaring directory. Suppose you are not interested to declare any directory. You want to keep data anywhere, and then you want to import it in there. In that way, you have to know where you have saved your data. Okay. So suppose I saved my data in this folder. I just went to the right click on that folder, and then I went to the properties and copy the path of the data and plug it in there. In that way, data has been imported to the Python. So cursor will be blinking on a line, and then if you hit Control Enter, then the data will be imported. So my data has been imported. Okay. After that, now I want to do what? I want to do first question, then the fifth question. So question 1, 2, 3, 4 is done. These are the questions is already done. Okay. These questions are already done. Now I am to do question number 5. Check the number of observations, rows and variables in the D1 data. The data that we brought, on that data, how many rows and how many columns, or how many observations and how many variables are in that data, we want to find that. In order to find that, we have to just write this one, line number 28. Then the D1 data, which known as the class practice data, has 20,900 rows and 25 columns. Okay. After that, Now the question number 6 is telling you sort the name of the columns of the D1 data by ascending order and name as a S1. So question number 6 is asking you, you have a data, right? So let me show you the data. So D1 dot head, if I write it in here, you are seeing the data looks like this. So in this case, in this data D1 dot head, where we see the first 5 rows, we see the name of the columns or name of the variables. But this name of the variables are not in a ascending order. So they have a name, ID, race, income, and then age, smoke, pulse. I want to sort the data frame D1 in such a way that name of the columns will appear in a ascending order, in alphabetical order. How can I do that? In order to do that, we have to run this line of code. D1 is my data, sort by indexes. Index is what? X is equal to 1. X is equal to 1 means column, X is equal to 0 means row, and ascending order. So let us run this line of code and then check, and you will see. Now see, everything is coming in alphabetical order. Everything is coming now in alphabetical order. So what we have learned from the question number 6, if you have a data frame or data that has lot of variables, but the variables name are arranged in a random pattern, random manner, how can you arrange in a alphabetical order? That thing could be known by running a line of code, which is line number 33. Okay, so how can I sort the data in a descending order? That is what could be obtained by running line number 38. Line number 38 will give us opportunity to sort the data by a descending order. So instead of ascending order, descending order. So question number 8 is telling you how to sort a data frame. Now, question number 6 and 7, we sort the data frame by the column name. Now, question number 8 is telling you, in the data frame D1, there is a variable age. Age variable, all the values in the age variable will come in a ascending order. Lowest value is coming first, then second lowest value, then third lowest value, then that way it will. So now I am sorting the data frame, not by column name. I'm sorting the data frame by a variable. How can I do that? That could be done d1 dot sort underscore values by age variable. So if we run this, then we see that data is sorted by age variable. Take a look at that. Now take a look, age variable. This is the way it is coming. So 8.96, 8.97, 8 point. So if I want to do this like tell, take a look, the highest value is highest value. That means these are missing value. Missing value is coming at the end. So that's the way. If any data frame, if you want to sort by a variable, so this is the line of code. That means line number 43. If you run, you can sort the data by a variable. How can you sort the data by two variables? Question number 9. You have to put the variables, and then you have to put ascending 2 times corresponding to 2. So in this way, they first sort the ID variable, and after sorting the ID variable first, then they will sort corresponding values of the age variable. So that is the way the data can be sorted by two variables. Okay. Now, question number, that is the question number 9. Now, question number 10, sort D1 data by age and the age and ID variable with missing values. 10 and 11 is asking you sort the D1 data by age and ID variable where missing values appearing first, and missing value where missing values appearing first, and name this shorted data as S1. Name this shorted data and name this shorted data as this, and name this shorted data as S6. Name this shorted data as S6. Okay. Name this shorted data as S6. So now, shorting data frame by age and ID variable with missing values appearing first. So take a look at that. This is a matching thing up until in here, and after there, I just put a missing values NA underscore position. I want them at the first position, and then here I want them at the last positions. Okay. And then here I want them at the last positions. So question number 10 and 11 is telling you how to sort a data frame by variables where missing values are appearing in the first positions and missing values are appearing in the last positions. Now the question is, once you sort by age, corresponding to age, missing values will be preferred to put first. Similarly, missing value corresponding to the age will be put first to put in the last, because I am interested to see missing value should appear in the last. Okay. After that, 11, let me go for the 12. Create a DF1 data frame from D1 data frame by selecting only first visit. So now this is a longitudinal data. What is longitudinal data? Longitudinal data is a data where repeated measurements of the subjects are seen. For example, suppose in the class there are altogether 30 students. Okay. I want to take their blood pressure, height, weight, cholesterol level, sugar level once in a week for the next 7 weeks. So that means each individual measurements are coming 7 times. If in a data, same subject, same person is measured multiple times over a period of time, then that data is called the longitudinal data. There is a two types of longitudinal data, one called balanced, another one called unbalanced. So what is the difference between balanced and unbalanced longitudinal data? So balanced longitudinal data means, suppose there are 30%, each person will be measured exactly 4 times. So 30 times 4, so that means 120 measurements, 30 times. On the other hand, if 30 persons, one person measures 7 times, another person measures 3 times, another person measures 5 times, there is not a balance. Some are getting more measurement compared to the other over a period of 2, 3, 5, 6 years, or 2, 3, 5, 6, 7 months, or 10 months, or 10 weeks. Then that data is called the unbalanced longitudinal data. Okay. After doing that, now let us do create a DF data frame from D1 data frame by selecting only first visit. So if a person has a 10 visit, I want to select his first visit. If a person has 7 visit, I will select only his first visit. Similarly, if a person has 9 visit, I want to select his 9th visit. Another person has a 7 visit, I want to select his 7 visit. That means last visit. That is the questions. That are the questions in 12 and 13. Create a DF1 and DF2 data frame from D1 data by selecting only first visit and last visit. So let me take you there. So this is the data ascending order, and then S1 is the data which I am sorting by ID and age, which I sorted. After that, I have created the new data that will have only fast observation. So now take a look at the dimension of the data, which is equal to np dot shape. And there, in that case, you will see that has a 2379 rows. Okay. Alternatively, you can also do these things. That is much easier. If you do these things again, you will get the same results. Okay. So line number 67 and line number 64 and 65 are giving the same results. So line number 67 has an advantage because this is just a one line of code. Okay. After doing that, similarly, we can do it for the person to select the last visit. So which we have done. So let us now do the question number 14. Let us read the question number 14 from there. Check the names of the variables of D1 data. In D1 data, what are the names of the variables? How can we check that? We can check that by just running this. So the D1 data has the altogether 24 variables which are in mentioned, which can be seen quickly. Okay. So this line of code 79 is important because if there are a lot of variables, how can you find your variables very quickly, easily? That is the approach. More importantly, if you do this, if you run the code, if you run the line 79, if you run the line 79 after sorting the data frame by columns name, then the column names will appear in alphabetical order. In that way, you can easily find your variable of interest. Okay. So you have seen how to see the names of the variables. Again, what I just said, let me tell you again. Before seeing the variable's name, if you sort the data frame by the column names, in that way, column names will appear in alphabetical order, which will help you to quickly identify your variables of interest. Okay. So now come checking the types of the variables. Here I have seen ID variable is the integer 64 format and raise variable is also integer format. That means this is a categorical variable and float means quantitative or continuous variable. So what are the types of the variables? We can see it from there. Line number 85. Line number 86 is the float. 64 means it is a quantitative, or more specifically, if you want, it is a continuous variable they are considered. Let us confine ourselves like quantitative and qualitative. Okay. So, or categorical, something like that. So what we have learned from the line number 86 or question 15. So there is a variable, some variable are categorical, some variable are quantitative. This is what we have learned from there. Okay. Now I want to take a look at the first 5 rows of the D1 data, which we can do like this, and the last 5 rows of the data, which we can learn by using that. Okay. So after doing this, now if someone interested to take a look at the first 100 rows, which could be done like this. So Python start from 0, Python ends in 99. Okay. So 0 means, and also 0 means row. When we put it in dimension, when we want to compute something by dimension wise, then we have to put here 0 and 1. 0 stands for row, 1 stands for column. Remember these things. Also, Python starts from 0, 1 to up to 99. I put here 100, but I see there are 99. I put there 100, but I see there 99. So now, but it started from 0. Take a look at that 0. Okay. After that, now let us consider I want to create a new ID from the existing ID. So existing ID is a number. I just want to subtract a random number from that ID so that new ID could be created, and then I will delete original ID. In that way, the person is de-identified. You cannot identify the person. Even the person come and ask you, my ID number is this, you cannot find that person. Why? Because this ID number is changed. In that way, like data manager or data scientist sitting in the top positions, they give you the, if there is any confidential data and there is a non-disclosure agreement, NDA, and in such cases, data manager will give you for predictive modeling, for machine learning modeling or data analysis, data mining, summary statistics. The manager will give you the data, but manager will corrupt ID number. Corrupt ID number, or change the ID number so that you cannot identify who is who. Okay. So you can do that by just writing this line number 100. By running that, we can change the ID number. As I have changed the ID number, now if you take a look at that, D1.head, previously 50,000 was the ID. Now the new ID is 111. So now you cannot identify because you do not know what mathematical operations I have conducted on original ID variable to create a new ID variable, because I only know. And after writing these things, then I delete this original ID variable has been deleted. Take a look at that. Now, original ID variable is gone because I ran the line number 104. Now, these data I can give anyone. These data I can give anyone. You can go and work with this data and give me some statistical model fitting, predictive modeling, some summary statistics, and some graphical representations. Nobody can identify the people. Okay. Nobody can identify the people. Okay. So after doing this, now I want to find the summary statistics. Summary statistics could be obtained by writing this thing. So this is the way income variable has that many observations. The mean of the level of the income is this. Maximum is 1, minimum is 1. Sorry, maximum is 9, minimum is 1. That is the way. And that is the way you can find the descriptive statistics for the entire data frame. But if you are interested to find the descriptive statistics of two variables, that could be obtained like that way. Two variables, okay? And then summary statistics of a variable you can obtain like that way. Summary statistics of a variable, one variable. Previously, question number 20, summary statistics of the two variable, and question number 21, summary statistics of the one variable. Then question number 22 is asking you how many missing values for each variable in the D1 data frame. How can I find that? D1 is the data is null dot sum. In that way, I get that race has a 0 missing, income has a 1158 missing, smoke has a 9889 missing, which is the highest missing values. No, TC means total cholesterol has 13,389 missing. TG has 13,392. These are the corresponding number of missing values. Okay. Suppose you have a data set. In that data set, you want to know which variable has the highest missing values. You have a data set. From that data sets, you want to know which variable has the highest missing values. So that's the way. If you run the line number 119 or problem 22, you will get the number of missing values. Now, in the data, there are rows. Rows means observation. That means one person's and various observations on him. Various observations on him means various observation on him means his height, his weight, his body mass index, his cholesterol, his blood pressure, his triglyceride, his many thing. Okay, many things. Okay, how can we do that things? Mm, like which how many missing values corresponding to each row can be obtained by using this, okay, by using this we can create a and miss. So if you write here d1 dot head, then take a look, and miss variable has been created, and miss variable has been created. In this and miss variable we find corresponding to rows, first row we have a 1 missing, corresponding to row 2 I have a 4 missing, corresponding to row 3 I have 0 missing, corresponding to row 3 we have 4 missing, corresponding to row 5 I have a 0 missing. So we have learned from here how to create a variable from the data, so that variable will show the number of missing values corresponding to each row. This is what we learned from question number 23. Now, any row in the D1 data, if have missing values, I want to delete that row. That could be obtained by question number 24. Question number 24 is telling you delete any row that has a missing value. Question number 24 is telling you delete any row that has a missing value. So now take a look at the dimension, difference in dimension D1 and D2. So if you write here np.shape, D1, you get this. Then if you sheet np.shape D2, then you will get this. So you see significant reductions of the number of rows. Previously, there was 20,900 rows, 26 column, and now there are 1,942 rows and 26 column, 2,000 rows. Okay. So significant reductions. It is not like 50% reductions. It is um, we have to compute it, what percent that reduction is. So 1942 times 100 divided by 20900. Okay, so significant amount of reductions in the number of cores. Now 25 is telling you to find the shape of the data, and then this is the, and then 26 is asking you find the summary statistics of the D2 data, which does not contain any missing values, okay. And then 27 is asking you find the standard deviations of the D2 data corresponding to each variable, that is the standard deviation. And if we want to find the standard deviation for the continuous variable, first of all, we have to find which are continuous variable or quantitative variable and which are not. So uh, we find that race, income, smoke, waste, waste, and event, these are categorical variable. These are not quantitative variable. So we find that, and then we write a very beautiful code, irrelevant and relevant. In the relevant part, we write variable for variable in the D2 dot columns, if variable not in the irrelevant. So I ask you, advise you to read line number 142, which is so beauty. See, it is just complete English we are we have written, right? Complete English. And then we just find that relevant variable from the D2 data, we are finding the standard deviation. Okay. Then after finding this, then we find D2 data, standard deviations for the SBP, mean for the SBP, minimum for the SBP. That is the way you can also find from the D2 data. And now in question number, okay, let us stop in question number 28. In my next video, I will cover from question 29 to 60. Okay, I'm going to stop in here now because I don't want to make a long 2 hours video. I want to make short video. So let me stop in here.